Okay, let's discuss question number 18. Somebody unmute the mic and read question number 18. Somebody please read it there.
A metal box is placed on a rough horizontal table. An object of mass 10 kg is connected to the box by the light inextensible string. The string goes over frictionless pulley and the objects move with a constant acceleration as shown in the following figure.
That's a mistake. Constant acceleration as shown in the following figure. Right. So the surface is said to be rough. It means friction forces are acting on this 12 kg object. So what are things that they have asked? Read the other questions also, dear. Please read the rest of the questions.
The mass of the box is 12 kg. The coefficient of friction between the box and the table is 0.4. First question, find the friction force. Calculate the acceleration of the objects. What is the tension in the string? If an object of mass 30 kg is kept on the box, what will be the new acceleration?
Okay. Right. So thank you. Right. Let's give a try. Let's give a try for this. The coefficient of friction between the box and the table is given as 0.4. Okay, I think you remember what the kinetic friction force. Right? Let's give a try. I think you are able to see the board. Yes.
Yes.
Right.
Yes, sir.
Let me draw the figure. That's the question. Yeah. Right. Okay. So this is question number 18 of 600 questions tute. There is a box of mass 12 kilogram. Right. It is kept on a rough table. It means the friction forces are there. Then there is an object of mass. How many kilograms? Some kilograms. They are connected by a light inextensible string. They are connected by a light inextensible string. Right. Please draw this figure. After that, let's mark some of the forces acting on these objects and let's give a try. Draw it there. 12 kg and 10 kg, right? Those are the masses, 10 kg and 12 kg. Don't worry, I'll send the question to the groups. Don't worry. Whether you have a tute or not, it's not a problem because I always send you the questions to the group. Photos of the questions are always sent. And some students said me that they received the tute. So others will also receive the tute. Don't worry. If you are not sure, I can send you the screenshots of the students send me that, right? So weight of this object acting downward, let me mark it as M2G. The tension in the string is capital T Newton. This is how we always mark the tension forces. And weight of this object is acting downward as M1J Newton, the normal reaction force acting on it, let me mark it as R1 Newton. When the object is moving to this direction, a friction force acting on it. So let me mark FA Newton. So FA Newton is the friction force. FA Newton is the friction force. Okay, complete. Draw it. Right, let's give try to draw the free body diagrams. Look at board here. Before the free body diagrams, we can find R. You see, if you consider this 12 mass, there is no vertical motion. There is no vertical motion for 12 kg object. So as there is no vertical motion of 12 kg object, means 12 kg object is not moving up and 12 kg object is not moving down. So therefore, the upward force acting on the 12 kg object should be equal to the downward force acting on the 12 kg object. Got it? If R1 is bigger than M1G, object will be moved up. If M1G is bigger than R1, object will be moved downward. So as the object is not moving up, as it is not moving downward, R1 and M1G should be the same. So therefore, we can write that R1 equals M1G. M1 is 12, G is 10. Therefore, R1 is 120 Newton. The normal reaction force given by the surface to the 12 kg object is 120 Newton. Right, India? Right, now we know the normal reaction force. So let's try to find the friction force. As we know the capital R, now we can find the friction force. So let me write friction force. I have marked it as Fa. All the friction forces are equal, a constant into normal reaction. So friction force equals mu R. Here R is R1. Mu is given as 0.4. R1 is found as 120. So 0.4 can be written as 4 by 10. This is 120. Then what will happen here? This 0 and this 0 can be cancelled out. 0 to 0 can be cancelled out. So what are the remaining terms then? 4 times 12 is 48. So the friction force is found as 48 Newton. Complete it here. Right, now I think you are able to see the board. If you have any doubt, you can ask me, right? Just unmute the mic and ask or send me a message to Zoom chat. Uh, 0.4 is given in the question. They have given the value of mu as 0.4. If you read the, let me read the question for you. The mass of the box is 12 kg. The coefficient of friction between the box and the table is 0.4. So mu is said to be the coefficient of friction. That value is given in the question. Check your WhatsApp groups. I have sent you the figures. Yeah, I have sent you the question to WhatsApp groups. Dear, please check. Still, I did not post the 600 questions to because still there are some physics teachers in the class. So, and they have not paid me the class fees. So therefore, I did not post the tute. I did not post the 600 questions tute because there are some teachers, physics teachers are learning physics free of charge. They don't pay me the class fees. If they pay me the class fees, no problem. I am ready to pay, post it because it costs a huge amount to post as well as to print that one. 600 question tute is very much bigger than 2 CR books. So if those tuition teachers who teach physics, who learn physics from me free of charge, if they pay me the class fees, definitely I'll post that tute also. I don't care about it. Right. Until that, I'll send you the pic. Yes, for the paid students, I have posted other tutes, but not the 600 questions tute there. Got it? Can you understand difference there? And there may be delays in tutes. That is possible, right? Because this is Sri Lanka. Whether you have the tutes or not, you have the images until the tutes are received. You have the photos of the question, so there is no problem whether you receive the tutes or not. Some students, they have already received them, some have not received, but it's not a big problem. Because if you check the WhatsApp groups, all the questions are, photos of all the questions are sent to the WhatsApp groups. So if you are a really working student, just read the questions and do it. No problem, right? Right, so we know the friction force. Now I'm going to apply, look at board, I'm going to apply F equal MA to this object. Only to 10 kg object, only to 10 kg object, vertically downward, let me apply F equals MA. Right? Only to 10 kg object, vertically downward, let me apply F equals MA. There are two forces acting on the 10 kg object, M2G and capital T. The downward force M2G, the upward force is capital T. Therefore, the total downward force is M2G minus T equals M2 into A. Mass of the second object is given as 10 kilograms. So M2 is 10, G is 10. Minus T, this is 10 into A. So 10 times 10 is 100. Minus T equals 10A. Let me mark it as the first equation. Right. Okay. So let's apply F equals MA only. Let's see. Let's apply F equals MA only to 12 kg object. To this direction, we can apply F equals MA. The only force acting in right hand side is capital T. The friction force is acting to the left hand side. The mass is 12. Acceleration is A. We have found FA force. We have found FA force. We have found FA force. The friction force we have found it as 48 Newton. So T minus 48 equals 12A. So let me mark it as the second question. Write it there. Right. So the easiest thing to find acceleration, the easiest thing to find acceleration is just adding 1 and 2 equations. 1 and 2. If you add 1 and 2, the first equation 100 minus t, the second equation t minus 48 equals first one is 10a, second one is 12a. You see this minus t and plus t cancelled out, minus t and plus t cancelled out. The remaining terms 100 minus 48 equals 22a, 22a. 100 minus 48. So 10 minus 8 is 2. 9 minus 4 is 5. 52 equals 22 times a. Therefore, acceleration equals 52 divided by 22. Can you simplify this further, dear? Give a try. Yes, I said about A-level teachers. A-level teachers, yes. Advanced level physics teachers. Right. Okay. Is this correct? 52 divided by 10 and 12, 22. Can we simplify this any further here? Can you simplify this any further? A equals 52 divided by 2. 5 divided by 2 is 2. 4, 1 minute. 12 divided by 2 is 6. 22 divided by 2 is 11. 26 over 11 meter per square seconds. Is this correct here? Who got this answer? Who got this answer? Here it's okay to leave the answer as a fraction, but in the examination, you have to divide it, right? You have to divide 26 by 11 in the examination, but here it's okay to leave it as a fraction. But in the main examination and even in school term test, you must divide it. But using fractions is very good way to simplify. It's very easy to simplify when we use fractions. So let me show you the method that we use to find the tension force. For example, let me use the let me use this second equation. Let me use second. Look at board here. Let me use second equation to find the tension force. Just look at board. T minus 48 equals 12A. T equals 12A minus 48 comes this side as positive 48. Got it? I have taken minus 48 to this side as positive 48. Still, I did not substitute the value for the acceleration. Give me a try. T equals 12. A is 26 over 11 plus 48. And then, so T equals, let me take common denominator as 11. So 48 should be multiplied by 11. That's how we take a common denominator. We have to multiply this 48 by, please wait until I simplify. 48 should be multiplied by 11. Then only we can find the, then only we can take the denominator as 11. So 12 into 26 minus, plus 11 into 48. So easiest method for this, 12 into 26 plus 11 into 48 can be written as 12 times 4. Am I right here? 12 times 4 is 48. Please check. 12 times 4 is 48. Now you should understand that this 12 and 12 is common. So 12 can be taken out from a bracket. So T equals 12 can be taken out from a bracket. So what are the remaining terms? 26 will be there. Plus 11 into 4 will be there. Because I have taken 12 out from a bracket. So then this is 12, 26. 26 plus 11 times 4, 44, divided by 11. Divided by 11. Okay, dear? Please complete this and try to find the tension force. Give a try. If you leave this as a fraction, they will reduce 1 mark. You will lose 1 mark if you divide, if you do not divide this, dear. So you don't have a real idea about, so I read all the messages sent to the Zoom chat, so you don't have any idea about the teachers and the institutions. So පොඩි ළමයිනේ තේරෙන්නේ නැහැ මොකක්ද ඇත්තටම වෙන්නේ කියලා. But it's good. So your minds are not polluted. That's why you are telling me that kind of things. Good. But it's not easy to work in Sri Lanka. Right. Okay. Look at board. This is 12, 26 plus 44. 6 plus 4 is 10. 4 plus 2 is 6 plus 1, 7 divided by 11. 7 times 2, 14. The 0 is there. 7 plus 7 times 1, 7. Plus 1, 8. 840 divided by 11 Newton. So this is the answer for question number 18. Okay, I think you have written. Shall we go to next question, dear?
Yes, sir.
Okay.
Right, let's give a try for the question number 19. Fifth, 18 we considered, right? No, there's another part in the question. If an object of mass 30 kilogram is kept on the box, what will be the new acceleration? Wow. So what have they done? They have kept another object of mass 30 kilogram on the box. Box means this 12 kg one. Box means this 12 kg one. So if they have placed a mass of 30 kilogram on the 12 kg object, what will be the new acceleration? So let's give a try. So then, look at board here. So if we place a mass of 30 kilogram here, right, its weight will also be acting downward as M3G. M3G. The tension force, now let me mark the new tension force as T2. Tension force may be changed. All the other things remains unchanged. Sorry, R will be changed as R2. Earlier it was R1, now it is R2. And the friction force, definitely the friction force be changed. Please mark the new friction force as FB Newton. Draw the figure here. Draw this figure again, because by keeping this 30 kilogram mass, please draw this figure quick. Okay, let's give a try. But now you have to write a small description. Please try. The 12K, please write a small description. I will not erase the figure, I promise. So please write. There is no, the 12 kg object and the 30 kg object. The 12 kg object and the 30 kg object. The 12 kg object and the 30 kg object are not moving vertically upward and they are not moving vertically downward. The 12 kg object and the 30 kg object are not moving vertically upward and vertically downward. The 12 kg object and 30 kg object are not moving upward and not moving downward. Full stop. Therefore, continue the description. Therefore, the forces acting vertically upward, therefore, the forces acting vertically upward therefore, the forces acting vertically upward should be equal to the forces acting vertically downward. Therefore, the forces acting vertically upward should be equal to the forces acting vertically downward. Okay, dear? Right.
Sir, can you please repeat once again?
Yes, I'll repeat. Hagandarune. The 12 kg object and the 30 kg object, the 12 kg object and the 30 kg object are not moving vertically upward and are not moving vertically downward. The 12 kg object and the 30 kg object are not moving vertically upward and not moving vertically downward. Full stop. Therefore, forces acting vertically upward should be equal to the forces acting vertically downward. Therefore, the forces acting vertically upward should be equal to the forces acting vertically downward. Right, look at board here. The only upward force is R2, M3G and M1G are acting downward. So upward force must be equal to the downward forces M1G and M3G. M1 is 12, G is 10. M3 is 30, G is 10. So we will get 120 plus 300. So then we will get 420 Newton. Write them all here. as R is changed, the new friction force can be calculated by using the new friction force equals mu R2. R2 is 420. We found it. Mu 0.4. 0.4 can be written as 4 over 10. So this 0 and this 0 cancelled out. Then we will get 4 times 2 is 8. 4 times 4, 16, 168. What was the earlier friction force? I don't remember it.
48 newtons, sir.
48 Newton. Yes, thank you, Buddha. Thank you. 48 Newton. Right now, we do the same thing as earlier. Only to 10 kg object. Only to 10 kg object. Now, I'm not giving you the MCQ method. I'm giving you the essay questions method here. Only to 10 kg object. Vertically downward, I can apply F equals ME. So downward force is M2G. The upward force is capital T equals M2 into simple A. M2 is 10, G is 10 minus T. The new tension force is T2. This is 10 into 8. 10 times 10, 100 minus T2 equals 10A. So let me take this as my capital A equation. Write it. So what should we do next? Somebody please tell me the next step here. I have applied F equals MA to this one. So what should I do next?
So you should apply the
You
this
should
one
apply
to
it to the 12 kg
12,
object.
42 kg object.
Very good. If we should apply F equals MA to 30 plus 12, 42 kilogram. You see, I'm very happy when students answer my questions. I fight with students only for one thing. I never force students to pay class fees. I never say you must pay the class fees, otherwise I will not send you the Zoom link. No, I don't fight with the students for that. The only thing that I fight is, I blame is when I ask a question, some classes they do not answer. That's the only thing when I get angry. If you are in my class, if you learn, when I ask a question, you must give answers. If you have learned, you must know the answer. I'm so happy with this 23 batch because whenever I ask questions, you always give the answers. I'm so happy with you. Keep it. It's a good quality. Right. So then let me apply F equals MA to this the 12 plus 30 kg objects. We apply F equals MA only to 30 plus 12 kg combination. We apply F equals MA only to 12 plus 30 plus 12 kg combination to this direction. The force, the horizontal forces, check the horizontal forces acting on this combination, T2 and the friction force. The T2 force, the tension force acting to the right hand side is T2. Friction force is acting against the motion FB equals the total mass is 12 plus 30. Acceleration is 8. We don't know what the T2 is. FB, we know it as 168. 12 plus 30, 42 times A. Let me mark this as B. Write them, dear. Write them.
Excuse me, sir.
Yes, I'm listening.
So in the structured essay part, sir, nearly how many points we should write to get the full marks, sir?
For structured essay question, yes, ask it properly, dear.
Yes, sir, for the structured essay question, sir, how many points should we nearly write to get the full marks?
So for the structured essay questions, dear, it should be taught separately, right? So when you have to learn how to write structured essay questions properly from under the guidance of a teacher. All the three subjects you have to, it means for biology, chemistry, and physics, the structured essay questions are very important questions. So you have to learn it separately. Within 1 or 2 sentences, I can't explain. So if you do not write exact answers, you will not get the full marks there. You will get nothing actually sometimes. So in our Sunday morning paper class, I'll teach you how to answer structured essay questions once I start them, right? So you have to wait. You have asked me a very good question, but answer is not simple. Right, so you have to learn. Right.
Okay, sir.
So
Thank you, sir.
yeah, I'm very happy when students talk to me and ask questions. The students ask questions means they are learning. If you do not learn, you will not have any questions. When you learn, you will have so many doubts, so many questions. I'm very happy when students talk to me. Right. So what should we do? What should we do next? Yanapute? What should we do next?
We should add them.
We should add
Add
both
the two
A and
equations.
B.
We should add the two
Add the
equations. You are very
two
good.
A
I'm so happy.
equation, B
So let's
equation.
add A and B equations. So this is the best thing that a teacher can ever achieve there. When students talk, when students answer questions, when students give their maximum. So that's the most important thing any teacher wants. I'm so happy about you. Good. So let's add A and B. A is 100 minus T2. B, T2 minus 168 equals 42 A plus 10A. So what has happened here? What has happened?
T2 will be cancelled.
Minus T2 and positive T2 cancelled out, and finally we get 100 minus 168 equals 52A. So what has happened here? Can you guess? Can you simplify this further? Acceleration will be minus. So what's the upset? Can you guess?
So there will be a deceleration.
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 Deceleration occurs.
Never. Deceleration no deceleration. Our typist, she has typed 30 when I asked her to type 3. That's the case. Typing mistake. So this should be 3 kilogram, not 30 kilogram. You see, this is 10, this is 12. Do you think that I will ever place third here? So now listen. Now keep 3 kilogram here and do all the calculations again at home. Get the photo and send to my WhatsApp. Homework. Got it? So this is not 30 kilogram, it should be 3 kilograms. So correct the mistake at home, do all the calculation and send me your answers to my WhatsApp. Do we have any more time for question number 19? I think you got it, right? Is it okay, dear?
Okay, sir.
Yes,
Okay,
sir.
sir.
Okay, sir.
Yes, sir.
Right, let's go to the next question. Question number 19. Let me read. A bullet of mass 0.4 kilogram is fired towards the stationary wood block. The wood block is kept on a rough horizontal surface. The mass of the block is 0.6 kilogram. After the collision, the bullet gets embedded in the block. They move as a single object. The coefficient of friction between the block and the horizontal surface is 0.4. Calculate the velocity of the block with the bullet just after the collision. So what is the law that should be applied to find that velocity here? What's the equation that we should apply?
Law of conservation of linear momentum.
Yeah, we must apply the law of conservation of linear momentum. So for the question number 19, I think we have enough time to solve that problem. Let's give it a try. If you are real students, you will stay in the class. Look at board. Question number 19. A bullet of mass 0.4 kilogram is fired towards a block. I don't remember the velocity. The block is at rest. Its mass is 0.6 kilogram. After the collision, the bullet gets embedded in the block. The bullet gets embedded in the block. It means the bullet will be at inside the block. The bullet will be at inside the block. Please draw this figure here, and they will start to move as a single object with a v meter per second. So at the time when the blocks start to move, do not worry about the friction. So we can consider friction later. So this is just, draw the figure there, please draw the figure. This is just before the collision. Just before the collision. And this is just after the collision. Please draw this figure here, quick. Let me mark the velocities. Don't remember. Yeah, bullet 100 meter per second. Block is at rest. Stationary block means block is at rest. Bullet moves with the velocity of 100 meter per second. The block is at rest. So what should we do to find this velocity here? What's the law that we should apply here? Somebody in the class?
The law of conservation of momentum.
Law of conservation.
Very good. So happy. So let's apply according to the law of conservation. According to the law of conservation of linear momentum, I can write that total linear momentum LM before the collision. Total linear momentum before the collision equals to the total linear momentum after the collision. Can you do the rest here? Can you do the rest and find the velocity?
Okay, sir.
Okay, sir.
I'm so happy with your comment, dear. Sir, we have discussed a similar question in the Sunday paper class. Yes, but what is the difference? What is the difference between the Sunday morning paper class question that we discussed? Very similar to this, but there is a difference. What is that difference, dear? Somebody? If you read the question carefully, you will find the difference. Yes, dear?
The wooden block is moving into the opposite direction.
Yeah, block was moving into the opposite direction. Here the block is at rest. But that's a huge difference than that. Try again.
It is tied to a string.
No string, yes. I'm so happy you remember my Sunday morning paper class, you see. So I should not worry about, because I'm not taking any fee for the Sunday morning paper class, but I'm very happy because you remember. One student said the block is in the Sunday morning class, block was moving. Now the block is at rest. And the second student told me there was a string in the question. The block was hung by a string. Very good. So you remember. So I'm so happy. That's the biggest thing that you can ever give to me. But the main thing is there is friction. There is friction there. See, the coefficient of friction between the block and the horizontal surface is 0.4. Find the friction force acting on the block after the collision. So you see, that's the difference there. Friction is also added into the question. That's the reason. That's the difference. It will give a huge difference to this question. Right. The total linear momentum before the collision is m1 into u1. The product mass into velocity is the linear momentum. If you are not learn linear momentum, if you not learn mechanics, you should stay in this class, right? Right. So m1, this is m2 into u2 equals, after the collision, there are no two objects, there is only one object. The mass of that object is combination of the two objects is m1 plus m2. The velocity is v. m1 is 0.4, u1 is 100. m2 is 0.6, u2 is 0. u2 is 0 equals, m1 is 0.4, m2 is 0.6, the velocity is v. 0.4 into 100 is 40.0. 0 into anything, 0. 0.4 plus 0.6 is 1.0. So it means v equals, what is v here? Somebody unmute the mic and tell me, what is the velocity of the block with the bullet after the collision?
40 meters per second.
40
40
meters
meter
per
per second.
40 meters.
40 meter per second. Okay, dear? Right, after that, they have asked the friction force acting on the block after the collision. So let me draw it here. If we draw this one, what is the total mass there? What is the total mass there? Total mass, capital M
1 kg,
is 0.4,
1
1 kilogram.
1
kilogram.
kilogram, sir.
1 kilogram. Yes, 1 kilogram. Yes, 1 kilogram. Total mass is 1 kilogram. Therefore, the total weight is acting downward. If the total mass is 1 kilogram, the total weight is acting downward as capital Mg. The normal reaction force is capital R. It starts to move with a velocity of 40 meters per second, and there will be a friction force. There will be a friction force. Right. Please draw this figure here. Please draw this figure. Because the next question is they have asked us to find the friction force. So draw it. Earlier I changed this. I have asked you to change 30 kilogram by 3 kilogram because it's a printing mistake here. Type, not a printing mistake, typing mistake. The 30 kilogram was a mistaken type. It should be 3 kilogram. Okay, dear. If you are disconnected earlier. So let's find R. We know that R is equal to mg because object is not moving up, it's not moving down. Therefore, the upward force should be equal to downward force. Then R and mg will be equal. Capital M is 1, G is 10. Therefore, R is 10 Newton. So we have found the normal reaction force. So how do you find the friction force? If the normal reaction force is R, what is the friction force, dear? What is the friction force? That is, friction force is mu1. Mu is the coefficient of friction. It is given as, I don't remember, the coefficient of friction. The coefficient of friction is given as 0.4. Coefficient of friction is given as 0.4. R is 10. 0.4 times 10 is 4 Newton. Roman number 3. What do you think about it? What do you think about Roman number 3? How much distance is traveled by the block when it comes to rest?